Bismillahirrahmanirrahim. Welcome to topic 6.2, critical section problem. Consider a system of n processes that is which consists of P0, P1, until Pn minus 1. So each process has critical section. So what is critical section? It is a section of code where shared data may be manipulated and a possible race condition may occur. So each critical section problem is to design a protocol whereby processes can synchronize their activity to cooperatively share data. So each process must ask permission to enter critical section in entry section. Okay, followed by critical section, then with exit section, then the last one is remainder section. So the general structure of process PI is shown in next slide. In the next slide, okay. So here we have entry section where we ask the permission. Followed by critical section, exit section, and the last one is reminder section. Okay, to where the remaining code is placed. So the entry section and exit section are enclosed in boxes to highlight this important segment of code. Okay, there are three requirements for solution to critical section problem. Here we have mutual exclusion. This requirement ensures that only one process, at a time is active in its critical sections. The second requirement is progress. It must not be possible for a process requiring access to a critical section to be postponed indefinitely. So this requirement, in other words, progress requirement, ensure that programs will cooperatively determine what process will next enter its critical section. The third requirement is bounded waiting. So it is a practice where it limits how much time a program will wait before it can enter its critical section. So another requirement, we have to assume that each process executes at a non-zero speed. No assumption concerning relative speed of the end processes. However, we focus more on these three major requirements. Okay, now we look at the one example of race condition. So for this purpose, we need to look at slide 6.5. Okay, so this is one example of race condition. So let's say we have two processes, okay, P0 and P1. Okay, both of them are creating child process using the fork system call. Okay, race condition happen on kernel variable that is next available PID, process identifier, okay, which represent the next available process identifier. Okay, so unless there is a mechanism to prevent P0 and P1 from accessing the variable of next available PID, the same PID could be assigned to different processes. Thus, we have to implement the mechanism of mutual exclusion that should be provided to guard against the race condition. Okay, so that's all for critical section problem. So thank you guys for watching.